So now let's talk about computing a determinant using the Laplace expansion method. Again, my matrix is going to be 2, minus 1, 0, minus 1, 2, 1, 0, 1, 2. And I'm going to identify this with A11, A12, A13, A21, A22, A23, A31, A32, A33. So these are the corresponding entries. So A11 is 2, A12 is -1, A13 is 0, so on and so forth. But remember that for the Laplace expansion, we have to figure out what the minors are. So let's do the good old-fashioned Laplace expansion along the very first row. So what's the formula for the determinant of A in terms of the Laplace expansion along the first row, right? Well, it's A11 times the determinant of the minor A11 minus A12 times the determinant of the minor of A12, and then plus A13 times the determinant of the minor A13. And so now what are A11, A12, and A13? Because we already have determined what A11, A12, and A13 are. They're 2, minus 1, and 0, respectively. So if we know what A11, A12, and A13 are, we're in good shape, right? Well, we just figure out which row and which column we have to delete from the original matrix. So A11 we'll obtain by deleting the first row here and the first column here. So let's go ahead and just plug in numbers now. So this is my formula. I write out the abstract formula and then I just plug in numbers. So A11 is 2, and I have determinant of the matrix obtained by removing the first row and first column, first row, first column, and that's going to be 2, 1, 1, 2. Now I have minus A12 is a -1 times the determinant of A12. I remove the first row and the second column, I get minus 1, 1, 0, 2. So go back and kind of look at that to think about it. And then I have plus A13, which is 0. So ultimately it'll cancel out, but let's finish filling in the gaps of the formula. I remove the first row and the third column, so I'll have minus 1, 2, 0, 1, right? This is this square matrix corresponding to everything that doesn't have row 1 or column 3 entry. So that's great, and we know what a 2 by 2 determinant looks like. So I have determinant of this 2 by 2 will be, well, I take the product of the diagonal terms and I subtract the product of the off diagonal terms. And so I'm going to have 2 times 2 minus 1 times 1. That's that determinant. Now this will become a plus, so I just have minus and -1, so plus the determinant of this guy, which is going to be -1 times 2 plus 0 times 1. And then of course this guy is going to cancel out. So what am I ultimately left with? Well, I have 2 times 4 minus 1 plus minus 2. Ultimately that gives me a 6 minus 2, which is 4. And of course that's not equal to 0, and so I know that this A is invertible. Of course I already knew that because of the inverse that I computed, but this is another way to verify that fact.